So let me introduce Eric Honor. Eric is a development consultant with Excella Consulting, someplace that I used to work. He is going to present today on Brownfield BDD, introducing behavior-driven design late in application lifecycle. So Eric, thanks for joining us. I'm going to go ahead and queue up your video and share your content. And I'm sending you live right now. So you are good to go.
Thank you very much.
Real quick, one other thing, I will be monitoring Q&A. So there is if you look up to the right, or I'm not sure where it is in your Teams channel screen, there is an active Q&A, which is live and open for this entire day and for each track. So if you have any questions for Eric, please feel free to post them in the Q&A. At the end of the session, I will ask the questions of Eric so he doesn't have to go through and read them. And we'll do our Q&A session at the end. And if you have any questions, go ahead and throw them in there as well. And Eric, I'll be standing by if you need me. Otherwise, take it away.
If I can actually make a request real fast. The way that I've got this structured, I typically do stop at 3 different points for Q&A midway through the session. Would it be possible to do that?
Absolutely, we can do that. The other thing I will warn you, if you remember that there is a significant delay, somewhere between 10 to 20 seconds. So when we get to that session, or we get to that point, there will just be a delay. So with that, take it away.
Okay. All right. Most discussions of behavior-driven design center around either abstract benefits or greenfield projects. I recently drove an effort to adopt behavior-driven design on a project containing more than 500,000 lines of code that had been in development for over 5 years and which had been in production for more than 6 months. I assembled this talk to cover some of the gaps I found in the available literature when working in that context. The content for this presentation is broken down into a quick introduction to behavior-driven design, followed by 3 sections. I'll be pausing for questions after each section and also at the end of the talk. Why BDD covers benefits that behavior-driven design can bring. Initial adoption covers early setup and things to consider before you begin. Managing growth covers what to expect as more specifications are added and ways that you can help smooth that process. First off, a note on terminology. The acronym BDD is often used as shorthand for behavior-driven development. I prefer the phrase behavior-driven design because it emphasizes that it's a practice that involves team members other than just developers. This is the point where normally I would ask for a show of hands, asking, is everyone aware of what behavior-driven design is, and asking if you're familiar with Gherkin syntax. Given that we've got a 10 to 20 second delay, I'm not going to literally ask people to raise their hands, but feel free to do so if you feel like it. In a nutshell, behavior-driven design is a set of practices to drive towards a shared understanding of how a software system works. Features are described in a feature file as a series of steps, phrased as given, when, then. For example, given I am on the checkout page, when I click the buy button, then I should be directed to the shipping options page. This syntax, the given, when, then, and also some stuff about how you define background, context, and scenarios and features, is called Gherkin. This gives a single, unambiguous description of how a stakeholder wants the specified feature to work. To prepare to take on the work of implementing that feature, the developer collaborates with the business stakeholders to create a file full of these scenarios that can check all the boundary cases that they might care about. In the example above, they might specify that given I'm on the checkout page and I have no items in my cart, when I click the buy button, then I am shown an error. Now, you might have realized when I set out that second scenario, I specified that there are no items in the cart. That uncovers a problem with the first scenario. It was implicit there that I had items in the cart, but the scenario didn't specify that explicitly. Determining these sorts of implicit requirements is one of the things that this collaborative process can help unearth. Once the feature file is complete, the developer writes binding code that uses regular expressions to match each step in each scenario with domain code. Some of those scenarios might pass if they're regression cases, but the expectation at this point is that at least some of them should fail, because the feature hasn't been implemented yet. The developer can then make whatever changes they need to until all the scenarios in that feature pass. If you do this for every feature, then as you go along, you can rerun all the existing feature specifications and confirm that the software does what everyone thinks it should do. Okay, so that all sounds great. Why BDD? In my opinion, the single biggest benefit of using behavior-driven design is that it encourages collaboration. Bringing developers' understandings of the domain closer to that of business stakeholders ensures that the developers are building the right thing from the start, which is great because it kind of sucks to be wasting your time building the wrong thing. Behavior-driven design directly contributes to two of the four core principles of Agile: individuals and interactions over processes and tools, and working software over comprehensive documentation. It addresses the latter by turning the documentation-software dichotomy on its head, making the documentation into executable code. It achieves the former through the collaborative effort that creates the feature specifications. The additional layer of shared language builds a bridge between the business's understanding and the literal logic implemented in the software. I'd like to highlight here that the biggest benefit comes not only from having the executable specifications in place, but also in the conversations that lead to creating that documentation. Developers creating bindings for steps that they wrote themselves limits this benefit. It's important to involve all team members in the feature writing process. If you often find yourself in a discussion with a user or analyst or product manager, and you hear them say something that you find yourself mentally translating into other words, that's additional cognitive overhead for you, and it also signals that the software, as implemented, doesn't align with how the business thinks about the process in question. Sometimes this is necessary. For example, if there are words in the domain language that are keywords in your development language, that'll always be tricky. But in general, mismatched terminology is a red flag. You might be familiar with a common solution to this known as driving towards a ubiquitous language, and that's a big part of what behavior-driven development can do. Another nice thing is that specification by example makes it easier to put a fence around what's covered in this work item. Often, feature requests aren't fully thought through, and even if they don't say so, what the person requesting a feature really wants to see is a version of what they're asking for that they then get to tweak and provide feedback and say, oh, can you do it this way? Can you do it that way? That can be a really painful process, especially if what seemed like a small tweak to them actually means changing how something was architected. Having concrete examples, which can then be verified by running the feature as an automated test, makes it easier to draw those boundaries around and prevent scope creep. It's easy for non-technical stakeholders to write off automated testing as just a thing that developers spend a bunch of time on that doesn't produce any tangible results. Involving them in the design of the tests clarifies what's important about the tests, since determining acceptance criteria is already a part of the process of requirement elicitation. That doesn't even need to take extra time. If you're in an environment where automated testing isn't highly valued, it can be worth spending a bit of time figuring out metrics that you can then present back to the other stakeholders. For example, a team might write acceptance criteria in Gherkin for some, but not all, of a set of upcoming work items, and then track the cycle time or acceptance rate of those work items. You can then compare those metrics for the stories that went through the behavior-driven design process with the metrics for those that didn't. If you're adding automated verification for every corner of every feature as you implement the features, then at the end, you have an executable confirmation that the software meets all of the agreed-upon specifications. Of course, we're specifically discussing the context of software that's late in the development lifecycle. This has the downside that the upfront work can feel slow, but there's a silver lining. In many cases, the correct behavior already exists. In some cases, I found it useful to describe a feature, implement the steps for it, and run it to see what happens, especially in cases where a new feature is being added, where I've been told like it should work like some other feature that already exists. Sometimes doing so even uncovers existing bugs in the current implementation that were corner cases that nobody had hit yet. Okay, so this is the point where I will stop and take any questions that have appeared. I will give, I guess, 20 seconds to make sure that I account for the potential delay. Okay, the only question I see is about the Discord link, and Scott helpfully posted that link. So thank you, Scott. We'll move on to the next section, initial adoption. Okay, this will be a quick summary of some of the important things to consider before you begin writing feature files. Most of these are discussions that should happen within the team and should involve testers, analysts, product owners, product managers, and any other business stakeholders, in addition to developers. On a Brownfield project, much of your context already exists. The tools, technologies, and environments are not only already decided upon, but also already set up and working. As much easier as that makes things, deciding what to test at a given layer can be complicated. Gherkin isn't a great fit for unit tests. Typically, you'll want to use BDD for entire features, not specific units of code. But what layer do you bind your specifications to? Ultimately, what you're trying to determine is what existing tools you can leverage. And there might be multiple tools. I'll cover this a bit more later, but the project I'm currently on is using both SpecFlow for binding features to C# code and a Cypress plugin for testing the UI based on Gherkin specifications. Next, you'll want to begin to have conversations with your team to come to an agreement on expectations around your specifications. Ideally, scenarios should be written as a collaborative effort between developers, testers, analysts, and other stakeholders. Generating buy-in on that can be tough, but if you present it as a way to increase communication, you may find that some people are much more willing than you expected. As a team, you should also consider whether all of your work would benefit from specifications in Gherkin. Some may be an awkward fit, and therefore the decision may be that you don't use Gherkin for those. And that's fine, but try to make sure that the team is on the same page about when to or not to, and try to make sure that other unit and integration tests are still being added. You'll also want to determine your phrasing, whether feature requests will be written in the first person, like given I'm on the checkout page, second person, given you are on the checkout page, or third person, given the user is on the checkout page. Some people argue passionately for one or another. My opinion is that it doesn't really matter, but you should commit to using all the same phrasing. This allows for greater reusability of steps. I find it's ideal to write scenarios out while the ticket is being fleshed out, possibly even doing research spikes before picking a story up to add the scenarios, some of which, the non-regression ones, will fail. You can then tag those non-regression cases that are failing so that they don't block your CI builds. Adding Gherkin feature specifications to work items in new domains will be much slower. Writing the bindings for concepts you haven't written anything around is a much slower process, especially as you find conceptual dependencies you didn't know you had. For example, a library's book tracking system might have a foreign key to an address table, so you can't just have a book, and instead, for that book to be a valid entity in your codebase, you might require a library and an address as well, even though the scenario you're writing doesn't require them. That's fine. Taking it slowly enough to identify those dependencies has the additional benefit of pointing to places in your codebase that might be streamlined, or providing feedback to the business that a given concept is overloaded with extra terms and functionality, and should maybe be split into other separate concepts. Next, you'll need to start identifying where within your codebase to begin to adopt behavior-driven design. This is easy when you're working on entirely new functionality. It's just whatever domain you're currently working on. But this can be harder if you're effectively adding regression tests to verify existing functionality, especially if your backlog is mixed across many domains. There are a number of possible strategies for this. Maybe there's an upcoming project that's a clear fit, an area that will be overhauled soon, or an area that will be safe to refactor because it's known not to get heavy use based on the time of year. Or maybe there's an area that's a dependency for many others, and so it would have to be tackled first regardless. Or maybe there's an area that you personally don't know very well, and you'd like the opportunity to get to know it better. Or, conversely, maybe a team member is leaving, and pairing up on adding scenarios that exemplify functionality that they know well can help transfer their knowledge to the rest of the team. Something that can be especially tricky in legacy situations is how to treat test data. The two common approaches are to have standard test data that you reuse, or to create entities anew in each scenario. I'll cover this a bit more later, but in using the builder pattern to add test data builders, you can greatly reduce the pain of creating new entities in each scenario. And doing so also has the benefit of letting you run scenarios in parallel. What I found works well is to create the new entities for each scenario, but to reuse common names for common scenarios, which helps build a secondary team language by giving narrative names to complicated business scenarios. Another consideration is whether developers can have test data on their machines at all, or if they're blocked from doing so. Pulling test data from a shared test environment can greatly ease setup, especially if many entities have complicated dependency graphs. However, relying on that data, being the same wherever it's pulled, whenever it's pulled, can make the tests brittle, which is another argument for creating data inside the scenarios. Finally, if your organization has a high reliance on manual testing, writing specifications in Gherkin can still be very useful. Something that I've had success with is debugging a scenario, putting a breakpoint on the when step, and then snapshotting the data tables that are relevant for the case I'm setting up. That data can then be provided to the tester to save them the setup time. This isn't a flawless technique though, since the setup bakes my understanding as a developer into how I structured the data. Because of that, it's important to be careful when to use this technique. Another big piece of advice I'd give is to keep your steps global whenever possible. That makes adding more feature descriptions much easier in the future. Come up with shared understandings of conventions for how features are described. This is really the more general version of what I mentioned earlier about agreeing on whether specifications should be written in the first, second, or third person. Another example would be what tense you write them in. Some teams will write the givens in past tense, the when in the present tense, and the then in the future tense. I think that makes sense, but really it's up to your team. This makes reuse easier not only on developers, but on everyone else, who can more easily intuit what wording to use. This also allows you to use automated tools to make your specifications available to non-developer stakeholders so that they can figure out what steps have already been implemented and reuse them insofar as they can. Another helpful strategy for cases where you can't keep a step global is to create a tag for what I'm going to call a frame of mind. For example, a bunch of these scenarios are extra verbose because we wanted to be able to reuse the ability to create a user. My recommendation would be to add a tag for scenarios that assume that there's only one user and leave the extra verbiage out of those scenarios. Okay, that takes us through initial adoption. I'm going to pause again for any questions that people have. And I do strongly encourage you to ask questions because when I do this talk live, I typically sort of try to do it as more of a discussion, and not being able to see people raising their hands and nodding along and stuff is it kind of weirds me out, honestly. So I'll give it another 20 seconds or so before moving on.
Again, if you have questions, the Q&A link in the actual Teams channel is where to ask. So go ahead and shoot away.
Okay, I'm not seeing any questions, so I will move on to managing growth. This section is focused primarily on ways that you can ease the transition from initial adoption to having a reasonably complete suite of accepted regression cases, and to making behavior-driven design a common practice within your project team. Your project structure will shift over time as you find different ways that different steps work with each other and that different domains interrelate. That's fine, and that's to be expected. If you've kept your steps global, that will ease the pain of changing the project structure. The first piece of advice that I can give is to remain flexible as things evolve. The second is to keep your step bindings, feature files, and plumbing separate. By plumbing, I mean the code that needs to be in place to integrate your test runner with your development environment. The big reason to separate step bindings from feature files within your project structure is to limit the implication that step files are bound to specific feature files, and to remind the team that steps should be globally accessible whenever possible. And I see a question from Brian. When introducing BDDs into an existing project, how did you have those discussions with the client? So I got really lucky in that as I was researching behavior-driven design, a mandate came down from on high that developers should no longer have data stored on their machine that is anything that even looks like production data. That stricture got loosened a little bit as time went on, but early on, like, it was literally, the manager walked in and took a look around and said, "Okay, everyone, delete your databases right now," and everyone was like, "Wait, what?" And so that provided me with an in to say, okay, well, that's really going to mess up our ability to test things on our machines. Here's a strategy that we could use that would allow us to do that without actually having stored data that mirrors production data. So that went over really well. There was a little bit of pushback early on regarding the amount of time that was spent on getting the BDD project set up. And the best way that I was able to overcome that pushback was mostly to pay a lot of attention to where in a sprint we were and wait for, it's a 2-week sprint. So the first week everyone's like really heads down on story work. But by the end, there's a lot of stuff that was in testing because the project I was on at the time had a lot of manual testing. And so in that latter half of the week, whenever something didn't come back to development, I was able to spend some sort of skunkworks time trying to figure out, okay, well, how do I, how can I start adding in this kind of testing to a specific domain? And that's something I'll get to in a little bit, which is how you decide which domain to approach first in a system that is already existing and is many thousands of lines of code. Adding builders for entities makes setting things up for specific scenarios much easier and lets you reuse that setup later on, even when the specific step you're working on for a binding is different. Your builders can also be kept in a separate module so they can be shared with other test code. At a minimum, having a with defaults method that sets up the bare minimum viable version of an entity can be helpful. One thing to be wary of is that if your with defaults method creates objects that it depends on, you may end up with extra copies of that dependency, especially if you set up another version in an earlier step. It can be useful to add objects that specifically track what entities have been created, so that your with defaults can, for example, reuse an already created version of a dependency if there is one, and only create a new one if one doesn't already exist. Scenarios that require multiple objects to be tracked separately across several steps can be difficult, because it's usually good practice to avoid globally shared data whenever possible. One of the pieces of plumbing code that you may end up having to write is a way of managing those items. Some frameworks have this built in. For example, SpecFlow provides a scenario context object, which is a dictionary that's shared across all step binding classes and is created anew for each feature that is run. Even if something like that is provided, it's worth looking for opportunities to extend that functionality for your own uses. For example, in cases where I know I'll only ever need one of something, I often add a method that uses reflection to get the type name and use that for the key. And then anywhere in my steps that I need it, I can ask the wrapper class for the default instance if it already exists, and if it doesn't, then it'll create a new one. It can also be helpful to have multiple different default methods, setting up more or less specific parts of the object in question for different clusters of scenarios. If your development environment offers reusable templating, consider adding templates for step bindings and builders to help smooth the way as people get accustomed to the process of writing binding code. This also has the benefit of letting you influence how they're structured to make things more consistent. Some plugins can also make this much easier. For example, when I use the go-to implementation shortcut in my editor on a step that doesn't have a matching binding, SpecFlow will step in and offer to copy an empty binding with matching code already in place to the clipboard. So I can then go to the steps file, paste that in, and I've already got a scaffold in place for writing the actual implementation. Generally, I find it best to have clear boundaries around what a given set of tests or specifications will do. I like to separate out projects for testing the UI, testing the backend, and end-to-end testing. Having these as discrete projects makes it easier to enforce that boundary. It can be helpful to add the same feature files to multiple projects and implement the same business case differently. For example, using the same steps bound to the UI, where one project's step bindings stub out all the server calls for front-end only testing, and another project's bindings use the real code for all server calls for end-to-end testing, which is more complete but also admittedly slower. It can also be helpful to use Gherkin syntax to define acceptance criteria for features that you never actually write binding steps for. This will still get you the collaborative benefits of behavior-driven design, though of course you'll miss out on the automation. It can be tempting to compromise by writing step bindings later on in the process. Doing so is better than nothing, but it can be difficult if you find that you need to change how things are phrased in order to make the test usable. Okay. That brings me to the final questions section of this talk. So feel free to ask any questions you've got. I'll give another 20 or 30 seconds for questions to come in. And I will also note that you can feel free to email me at eric.honor@gmail.com. And I'm going to hop over and join the Nova CodeCamp Discord once I exit this talk. Okay, I see another question coming in. Have you worked with any other BDD frameworks besides SpecFlow? Are there others that you would recommend we look at if we want to get started? So the project that I'm currently on, we use both SpecFlow and a plugin for Cypress. Cypress is a somewhat more modern alternative to Selenium for running front-end tests. So we actually have several different projects all defined, 2 for Cypress and 2 for SpecFlow. And the differences on those basically are what layers they test. So we have a Cypress project that tests only front-end code that stubs out all of the back-end server responses. We have Cypress end-to-end tests that test absolutely everything from the UI all the way down to the database. From the SpecFlow side of things, we have a series of tests that run against an actual database, and we have another project full of tests that runs only against entities that are stored in memory. So those execute a lot more quickly, but they also don't test, for example, key constraints in the database. And the prioritization and figuring out not only, okay, we're going to use Gherkin for this feature, but also, okay, well, what layers need to be tested is really important. A lot of examples that I see default to UI testing because it's kind of flashy. I actually tend to think that BDD works best when you're not worrying about the UI and you're instead focusing on what language the business uses. So if you walked up to a user of the system and said, hey, when you do this particular action, can you tell me what you do? They're not going to say, well, first I navigate to this URL and then I scroll down until I see this button and I click this button and then I wait for this to load. And then once this is loaded, I click this other button and I fill this form in. No, they're going to tell you, well, yeah, I go to this page and I fill in the data and then I wait for that to process or something like that. They're not going to tell you exactly what buttons they're clicking and that sort of thing. And in terms of driving that collaborative process, I generally find that using the language that your users use rather than the language that your web browser sees tends to be the best way to go. That said, it's really useful to have some form of UI testing to make sure that things appear as they should, and to automate your basic smoke test cases and things like that. And BDD can actually be a pretty good fit for that, as long as you don't mire yourself too far in specifying exactly what the UI should look like. Okay. I don't see any other questions, so I will hang out for a little bit longer in case anyone's typing anything and there's some lag. But in another 20 seconds or so, if there are no further questions, I will drop off and join the Discord server.
Great, Eric, thank you. As we wait for the questions to come in, is there anything else in your experience where you've other tools besides some of the ones that you mentioned that that people could use?
So there's one that I particularly like called Pickles, which is kind of a play on Gherkin, that generates HTML files of your document of your specifications. So you can publish that out to a live server and have a nice searchable way for non-technical users to see what features are described and how they work. You can even link that up to Cypress, which has visual, it stores basically screenshot states of all of the different browser states as you go through a given flow. And so you can have someone, you search for a given business flow and then find, oh, okay, cool. Well, I can actually watch what that looks like, even if it's an action I've never taken or something like that. Again, that tool is called Pickles. And there's lots of different frameworks for different languages. I've, again, primarily used SpecFlow and Cypress, but there's ones out there for Java, there's ones out there for Ruby.
Great. Well, I'm not seeing any attendee questions coming in. Again, if you have a question, the live event Q&A is out there. Feel free to go ahead and ask those questions for Eric. And after this session's over, as I mentioned before, we have a Discord server running with multiple channels and voice chat for all the tracks. Eric as you said you're planning on heading over to the Discord server, so he'll be over there for additional chat. Maybe Eric, if you could drop some links in the Discord channel on some of the tools you're talking about. So all that information will be over there. So I don't see any other questions coming in. So Eric, I'd like to thank you for taking the time to do your presentation and educate us on BDD, and hope you have a great day and a great weekend. And we'll look forward to talking to you over on the Discord channel.
Sounds good. Talk to you later.
Great, thank you.